तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
We were looking at simplified tool in order to synthesis or design, and we had a look at the schematics, so known as RTL view, and we will be looking at what is known as technology view. The technology view, as you see here, this is for RTL view, and which is invoked by this symbol, a plus symbol on the menu, and now we will be invoking another symbol. This is the technology view, and first I will read out what we need to do, and then we will go into the simplify window and then see learn more about it. Click on this symbol button on the top to view the technology schematic circuit diagram of the design. Use features such as zoom and advance from one sheet to another as in 8. We have already seen how to advance from one sheet to another, that is with horizontal arrows, and zoom also we have seen 1, plus, minus, and so on, and you can use what is called up arrows and down arrow to push or pop hierarchy. This will become clear when we look into the actual schematic. You can go down the level and have a peep into it. It may not be very much down, maybe just one layer or exactly the same thing that you see on the schematic on the top, technology view. Then as usual you have to study the circuit diagram to make sure that all the functionalities we have designed are in order, and this also I mentioned, this need not be done for every design, and it is only for the beginner to get ascertain that it is really doing the logic optimization, and from that point of view, at least once in your lifetime, I recommend that you go laboriously through this, and thereafter you do not have to go unless you have some specific doubt and in a particular circuitry. And you can also use this symbol, a clock symbol, and to see the cumulative critical paths and slack time respectively on the circuit. In fact, we have already seen in the view log file by opening which we could see the critical paths, and you could trace all the entire path and associated delays with gates, the propagation delays and so on, and how much what we specified and what finally it turned out to be, and if there is a difference, that is called the slack time. If it is positive, you have more cushion, whereas if it is negative, it has not met the constraint that you have asked for, and naturally it calls for either a redesign using heavier pipelining or bring down your actual frequency of operation to what is being reported. and that is what you have it here. Click on this symbol to see cumulative critical paths and slack time respectively on this circuit. Now we will open the simplify window to run the exactly the same thing. So we have here, in addition to that plus symbol, you have this technology view here. I hope you can see on the monitor. So I just click on this. What you see is the technology view, and I forgot to tell one more thing. So before we go for this, I have changed the design file from combination circuits to sequential circuits, and no matter what your design file is, it is exactly the same that you have to follow what you have done for combination circuits. It is absolutely the same thing irrespective of the design. So that is the beauty of this synthesis tool. You do not have to go much specific about your design for the time being, unless you are analyzing a portion of the circuitry. And so here I have already made 2-3 revisions here, so that I can expedite the explanation, so that I may not repeat the same thing over and over again. So I have added, same file is being used for all the revisions, and this is for sequential circuits. And if I click on revision 3, what it says is XCV50E, and package is 144 pin with a -8 speed. And if it is revision 4, I have XCV100E. This is the vertex highest speed possible, and this -8 is highest speed. I hope so. We will have a look into the results, then we will know whether it is so. And the package is 240 pins, and it is called PQ instead of HQ, I think we used earlier. And do not worry about the fan out, etc. What fan out is basically, and to what it refers is not clear from this. And it is a Xilinx Vertex C series, and we have one more here, and this is XCV100E PQ240-6. If you have a look at this implementations, let us say new implementation, this is speed. XCV100E is mapped here, selected here on this, and if you just click on speed, you will see 3 speeds, -8, -7, -6. I have deliberately chosen 2 of these speeds because we can make a comparison as to how much speed difference you can get. So that is the motive there. And in addition to this, we would also like to compare with another vendor, more or less same capacity, and I have done for another leading supplier for FPGAs, that is Altera. And one of the popular series in Altera is a Flex 10K series, and that is the device selected is EPF 10K 100A RC 240-1. And in Altera, I think smaller the number, higher the speed. You can experiment, although I have put only 1, and we will be having a look. I have already run all this, that is why you have it here, and you will straight away see the results. We do not have to run the same thing because we have already seen all that in combination circuits. And first we will have a look at this technology view before we proceed with this. Let us see, we will go for this XCV100E PQ240-8. This is the highest speed available in 100,000 gates capacity. It can accommodate approximately 100,000 gates plus RAM as well, and it is a 240 pin package, and this is the highest speed. And let us view the technology view. So what you have here in technology view is there are 7 sheets for this sequential circuits. So in sequential circuits, what you have, I will quickly go through what they are. So this is a sequential circuit, and what we had done is registers, and I am not going to the details. I am just asking you to recollect what you have done earlier. Then a counter we have done, and a mono shot we had done, retriggable mono shot, and then followed by a shift register, right shift register for 16 bits, and then a parallel to serial converter, and I think this is the final thing, state machine, and one more is there. There is a pattern sequence detector also. All these put together is what you see as sequential circuits, and this is the circuitry for that. It runs into 7 schematics, and as I mentioned, to wade through the schematic is a very difficult process even after optimization, and at least you must do for one of that, as I recommended earlier. And here what you can see is this is the technology view, whereas in RTL view, let us say how many sheets, it is only 2 sheets. So for the sequential circuits, if I blow it up, this is what you get here. Some counters are there, so you can see all that. You can just look at the outputs and then find out. So and this is for a mono shot, and shift registers here, and some D flip flop also we had realized, and you can just have a look like that. So it's quite cumbersome to have go through this circuitry obviously, and just imagine had you started with a schematic diagram, what will be your state. And it is, although it, here in contrast to that, we have seen that Verilog coding is much simpler. So you have only to just write some few assign statements or always statements and so on. So finally, when it is translated into circuit, it becomes very complex. And as we have seen here in the technology view, we have some 7 sheets. As I mentioned before, we can go from one sheet to another just by clicking this arrow. So right now it is on 2nd, then 3rd, 4th, and so on. 7th, 7 seems to be much simpler. So let us see this view. Even that is quite complicated. You can see output buffers, then some D flip flops which we couldn't see in the combination circuits, you can see here. And another thing that you have to learn is there is one up and down arrow here. If you click on this, and you can go inside this block. Let us see if any more detail is available. So what all it means is it's just a D flip flop with a reset pin, and it puts all the symbols for the signals that is being connected to this. So which will not be apparent if you go up. If you just click on this, it will take you back from where you came. So here it may be difficult. As I mentioned, you can disable this and then put the cursor and then find out what this signal is. Here it is so small that you can't read. I will read it out. That's a D input for this, and it's all same no matter what circuit it is. It is going to be either a combination circuit or flip flops, and all this you have already seen in log file, and so that's you have an iBuff here, and this is D input. So one inverter and all that buffers. So nothing more other than all these primitive cells that we have already explained. So 4 input LUT. You can just see 1, 2, 3, 4 inputs are there. So actual logic realized using the 4 input truth table, it's basically, and is what you see here, and with an inverter here, and so we'll. So this is the from this you can't have much information except when you go deep into the circuitry and find out what it has to tell you. And before we wind up this technology, there is another interesting thing which will show you the critical path as such. So you can see here it is exactly the same thing you are saying, except that there is some more available here. And what it means is, we can take here also. Here it says, two numbers are given here, some 1.8 and some 996. So one will be the cumulative delay, which one I forgot, and probably this one 996, all in nanosecond or in picosecond. It must be in picosecond, I think. In which case this might be the delay. associated, which we have already seen in the table earlier in the log file, and this one is the slack time. So, and there may be a plus minus. If you see somewhere else, and if you see a negative sign somewhere, you can make it out. Unfortunately, no negative signs. You can have I am almost sure the first one is the actual delay, and at this point, although this is put here, it means this delay is at this point after the not at the input but at the output, and that will be cumulative. So, the entire path you can trace and find out where more time is being taken, and thereby try to optimize by inserting a register by way of pipelining. And next one is, and that is what we have seen here. So, this would complete the schematic viewing as such, and let us see what we have further. So, we do not require, we are not going into the details, because our intention is only to do the synthesis and not analysis, which we have already done in the thing. And just as I mentioned, you can create .vm file and then input it to the simulator tool and find out whether the optimization has not taken away any wanted functionality. So, that is how you ensure that will be the fastest way to do, rather than go through the circuit diagrams, although a cursory glance can help. So, in this window, next what we will do is this we will dismiss this, because we do not require this, and it is asking for save, and unfortunately I have closed the window. Okay. Anyway, you do not require this. I have, because I have put it in a separate file. So, I will just tell that here. So, we have seen one device that is XCV 100-8, and in log file, if you see, it will report. I have just pasted here, and for what I told you that I should heed the warnings that the log file reports. See, for example, for this sequential circuits, there are two warnings given here, and one is, these are all the paths, and it implies the sequential circuits that we have taken as the design. And once again, I want to emphasize that no test bench must be given, but only your design, top design you have to give. And see, it says reports feedback mux created for signal SR 15 to 0. Did you forget the set reset assignment for this signal? It is just a warning, right? Because it does not find, let us see why it is reporting that. The warning that we have here is, did you forget the set reset assignment for this signal? Similarly, for one more signal, it gives the very same warning. Here it says feedback mux created for signal count PS reg, and once again it is asking the very same question. And so, let us see why it is. I have copied that portion of the Verilog code right into the same, and here what it is, and that is this code. So, what it has said is whether I have forgotten the reset, this is the reset portion for that particular signal, because it does not find those two variables here. Say this is the reset part of the block. The whole block will be nested, I mean if else if, that is the statement we have seen, and when the system is reset, then we need to reset only this I have said. So, it is asking, it is just reminding me whether I have forgotten those two signals, get the point. So, naturally this is a very alert state, and it is reporting, and but you have the right to veto it. You need not bother about the warning. if it does not make any sense or does not convey any sense, or it needs to be ignored. So, let us see here. So, what does it say here? Did you forget the set reset assignment for this signal? What is the signal? SR 15, and here count PS reg. Let us see that. So, obviously these signals are not appearing here, and let us see whether it is appearing elsewhere. For example, this count PS, actually if you see this PowerPoint here, I do not think it is available in this. So, let us it does not matter, because we have already seen earlier. So, what all we need to do is, the point is very clear. So, in reset these two signals are not taken into account. Why it was not taken into account? It is nothing but a shift register here, right, and we are setting data from input, and we are setting here. Since it is being loaded because of load condition, so we do not need to initialize when you reset the system, because what we need to do is first load the thing. I think it is pattern sequence direct, and so end of conversion, etc. are there, and we had also how many bits has to be sent, we put it in a counter. You remember, this is a pattern sequence director. So, what you see here finally is precisely this, right, but unfortunately you can't see anything from the state diagram. And so, what we have here is both of them are loaded and need not be therefore need not be reset. So, we veto this, although synthesis tool has reported. So, we not we just brush it off. That is what I am trying to say. The two warnings, right, are you clear? So, when you just because it has reported warning, we should not take it light. We should ponder over and find out whether we have really missed something in our design, and it may be a serious design flaw. Therefore, you always have a look at it, and then give due consideration to that, and then only make a decision whether to ignore the warning or not. Just because there are warnings, it will not prohibit you from going further, and but if there are errors, you can't go further. That should be borne in mind very clearly. And coming to these are all the other portion of the same code. Now, what we will see is this is a performance summary. We have got it from the log file, and this is for the device XCV 100E PQ 240-8, which we saw earlier, and how much, what is the speed it has offered. Let us have a look. So, this is not of concern. It says system, this is not a correct way of reporting. So, you can just ignore that. There was no clock and it is still reporting this, right. So, we had only one clock in this sequential circuit, I think, that is the clock, right. So, what is relevant is this clock, and have a look only at that. So, what the requested frequency is, what is the frequency here? I think I forgot to put the clock frequency there. So, it may so default it was 0 there, right. So, in the simplify window, if you take, we are supposed to put 100 here. I made an entry of 100 only subsequently. Earlier I had forgotten, it was just 0. So, although it was 0, it has put 0 conveys no meaning. So, it put it as 1 megahertz, but that is not a handicap here, because whatever is the actual thing achieved only will be reported here, that is what counts. So, in fact, we would have normally asked for 100 megahertz. Surprisingly, it has given 116 megahertz for this sequential circuit, whereas we are around 86 megahertz for combination circuits. So, we can't say which is superior, it all depends upon the circumstances, and ignore this here, and these are all nothing but estimated time, and so what matters is this, and the actual usage of different cells, primitive cells etc. are listed here. D flip flop 11 times it has used, then mux 2 input mux 17, exclusive OR gate, and other types of flip flops, and flip flops come under come in various flavors. So either enable or reset and so on. That's why different flip flops have been listed here, and how many times they have been used are listed here. So when you want to know the gate count of the your design, you will have to look into all this and take everything into account, including the number of lookup tables and I buffer, output buffer and so on. You can see the number of LUTs taken is 77. This does not mean 2 input or 4 input, there are an assortment once again. So that is what it is. So this is for XCV 100E, this is a vertex C series dash 8 speed. Now we will have a look at the very same results for another device in the same type. So only difference is dash 6. So series is same, package is same, 100,000 pack and 100,000 gates, and number of pins are also same, except that the speed is different here. So earlier it reported, just remember this, how much did it report? 116 megahertz. So that is for 240-8, and now it has climbed down, say just 100 megahertz it has touched. So that is the difference between dash 8 and dash 6. So based on this you can make a selection. Within there will be only very little choice, only 6, 7 and 8 are available in that particular type. And once again you can see how many, this will be probably essentially the same, say FDC 11, 17, 20 or something it was reporting, 11, 17, 20, 30, exactly same I suppose. And you can have a look at LUT, 77 here, and here also it is 77. So just 3% it has consumed, and with this we have made comparison in the same series but 2 different speeds. I will finish one more and then invite your question, right. And this one is we want to compare with another vendor, say we are comparing with Altera, whose capacity is more or less same. So this is 100 ARC-2, and in this case you get a lower speed, right. I may not be fully justified in making a one-to-one comparison without really seeing the actual speed the vendor has claimed. So the best way is see look into the vendor specification and see what their claim is, and then make a comparison, and then choose the right device and do it. And anyway I think I had taken the highest speed available in this category. Once again you can see 240 pin package, same PQ is not available in this. So whatever closest possible combination I have selected, and this is another series of 10K series, a popular series in Altera, just like Vertex C in this, and 100 again they have both this more or less the same meaning, and they also have a RAM etc. which is over and above this 100,000 gates, and so I think I am fairly justified in making comparison between the 2 vendors for on equitable platform. And here you can see LUTs, and total, if it is 100,000 gates, total number of LUTs that you can have is 4,992, out of which only 2% has been consumed here, and in the other case it was 77 or something, and here it has taken a little more. And then likewise then some more logic cells they call, that also has been used, and this is just merely number of nets, then some register bits are also used here, and and some they call EABs, some I don't remember the embedded blocks or something, I am not sure. So, have a look at the vendor specification and some cells, how many logic, how many arithmetic cells consumed and so on. And so, therefore, it will be very difficult for you to make a one-to-one comparison between one vendor and the other. It is not that plain or simple, and technology they might have adopted might be slightly different, and so it is not fair to make a jump to conclusion that this is superior to the other one and so on. So, both are in fact in the market. So, that proves that both are going to be there, right, and both are popular, and that is how you now you can ask if you have any specific question.
So, if I met the target frequency, then means my design has been successful, isn't it? Apart from the logic having worked out properly.
Yeah.
If the frequency target has been met,
yes,
my design is complete, isn't it?
Provided the functionality is also okay.
Assuming functionality is also.
Yeah.
Is there any other parameter I need to watch out for?
In fact, you have to take it through the next tool, place and route. These are all only, as I mentioned, they are all only a rough estimate. So, naturally, Xilinx place and route would not have conveyed to this simplify people all their proprietary information, right. So, and that is specific for their own product. So, so the delay reported in synthesis tool may not be exact, and it may not reflect the interconnection delays, etc. So, all that in addition to this primitive cell delays reflecting the actual thing based upon their own technology, their experience. So, naturally you can't get it on a third party vendor like Simplify. So, but still this gives an EDF file as an output, and which you can input to the Xilinx place and route in order to carry out the place and route, which we will be seeing later on. Okay, that is it as far as synthesis tool is concerned, and what we will do is we will go on for creating deliberately some errors, and both in Simplify as well as in Model Sim, and try to learn from that experience. It will not be an exhaustive treatment as such, and what is normally committed we will have a look, and based on that you can do it all by yourselves. So, only thing you remember is create an error in already working file. For example, let us say this all these codes are available to you on CD, let us say. I am not sure whether you will be getting the codes, but in case you have, the best thing is to take this, make it in make a copy in your any of your folders, and when you want to experiment, you make another folder and put another copy of this source file where you want to experiment. So, whatever you do with that particular duplicate copy, so suppose something goes wrong, so you can always copy from the original file and revert back to where you were if you get lost. So, while in the course of what I not to clarify this, in the course of making errors, you may overindulge and keep on giving very many errors and get drowned ultimately. So, if you get drowned, so easiest way to come out is copy back the working code and start from where you left, and so you stick on to making one error at a time, learn about that error and then rectify that error and then create a fresh error. So, in this fashion, this very same file which is a duplicate copy which you can destroy, it should not matter really. So, with that it will be a quick way of learning things. We will deliberately commit some errors during compilation. Let us see whether it will report any errors, and even during loading a design file errors may be reported. We will first try out one after another. As I said before, we will create only one error at a time, and even that we will make a copy your design files in some temporary directory and then make these experiments, because this this is like embarking on a dangerous expedition as such. So, if you do some grave mistakes, all entire file will have to be thrown. So, you be on your guard. So, preserve your actual file which is really working and elsewhere, and make the experiment in a temporary register, or you can designate it as a compiler error folder and copy your design files in that, and then make the experiment. So, to start with, we'll while experimenting we will see both the platforms such as Synopsys using Simplify as well as Model Sim for simulator. And let us take one error at a time. The error that I am going to commit is what I have observed over the years, not only myself committing these errors, but also other engineers or students committing similar types. So, one such error is, so this one, in fact this was my very first mistake when I started learning Verilog several years before, and I instead of this I put this, right. So, let me commit this error, let us see what it does. So, once you have made an just remember you have made an error here, and just save the file, only then it will get reflected there. So, now let us see, this Model Sim is opened here, and it is, as I mentioned, it is in compiler error folder, and this was in that etc. So, the actual files were there safe in etc folder, whereas I have copied only those two here in compiler error, and that is what you see here. And another specific point I need to mention is this, I will be running test bench here, because I have included the file, your design file in that test bench. So, when I compile this, automatically it takes this as well, design as well, and compiles. So, that is the difference I am going to make between the Model Sim, running the Model Sim as well as Simplify. In Simplify, the test bench has no role to play. So, I will be straight away running the sequential circuits there, and therefore, the mistake that error I am going to commit is only on the sequential circuits. I think you will agree upon that. And I have already made the error as I mentioned here, and I will just double click this compile, and then let us see what error it reports. See, here it has reported this. I will just copy this. See, in Model Sim, what we have done is what it is reporting, let us see. So, here you have it says illegal digit for specified base in numeric constant. So, what it means, this is not plain from here. Let us see, go to the Model Sim once again, and see what it, you do not require this for the time being, or just go to this, okay, remove that. So, this is the error. So, if I double click, it might open the source code. Let us see whether it does. Yes, it is opening, and it is pointing to the define statement which we made the error. This is the one here, right. That is precisely the error that we made. And if I click on the next one, and I think it does not report illegal digit for specified base. So, it is only as a consequence of that, it does not say anything further. I think it is pointing to the same, and I clicked on the next, it says warning here, and macro S0 is undefined, it says, and it is pointing to that where that S0 was used in the source code, and but this is only as a result of that defined. So, earlier what we had is this what we are having there. This macro S naught is undefined, it says here. Then one more error also it is pointing. Let us find out what it is. So here there is one more, and that is same. In fact, a warning and error point to the same, and there is one more warning and followed by again same S naught state it is saying, because that define pertains to S naught. That is why because that very first statement was not recognized, everywhere the same occurrence is reported as an error or warning, and you can see here also, and it is pointing to the same. So again some more warnings here, and always same S naught is being pointed out to. So you can see different lines, say 530, it reports which line number it is 530 here, and same S naught is appearing here. And now let us remove this error, and that is what you see here zoomed here. And okay, before removing, we did not see the simplify. Let us see what the simplify reports. So in simplify also we are in compiler error here, and let us see, we will run here. So here bear in mind that we are going to run the design file and not the test bench. So that is the difference here. Let us see whether errors are encountered, right. You can see view log and find out what the errors are. Say for example here I will copy this portion, I will just copy from the into this here. So this is the model sim error here, and simplify error is here, and you can all E stands for error, and you can see compile error, unknown macro S naught, exactly the same thing has been reported there. So because this is all because I mistook one symbol for the other, because both resembled, and in fact I have personally spent sleepless nights on this. So be on your guard, and it appears so simple to trivial thing, but the actual point is you may waste lots of time while debugging. And so let us see, we will create another type of error, and normally made by designers. So let us see how it is done. Before that, let us restore this to the original one. That was the symbol. So this is there at the point where tilde is on the extreme left of the keyboard. And next thing is, I have already made a mistake here. So module name I have misspelled sequential circuits. By mistake I put 2. This is also many people have done, especially those who are not strong in English. Of course here you do not need, and those who do not take care make a mistake like this. So let us see what sort of error it gives here. So we have rectified this. So there are no other errors. So we are right here on this module name, and first let us see the simplify. So we do not need the report. It says errors. Let us see what does it say here. If you double click here, it is showing same define with the previous mark here, although we had corrected. That is because I think it is already this file was open at the background, because I had another file here, so it did not get reflected there. So although I made the change here, let us see now the errors have disappeared. Are you clear about it? So, another source file, same source file was opened in this editor. So, what when simplify runs, only its own source file it looks for. So, if you had made any change outside, so it does not get reflected. So, you see that there are no errors here, and let us see, but we had committed an error there. So, let us go to model sim and find out. So, that is here, and in model sim, if I say compile, this is the test bench here which are going to compile. Let us see what it does. So, I compiled in model sim, and fortunately or unfortunately there is no error reported here. So, what we do is then this is a dangerous situation, right, and when you can't take it for granted. If you take it for granted, later on you will be surprised to see lots of functionalities are lost or the entire thing is lost. So, let us see how to whether somewhere else it reports. We have, once we had compiled it successfully, it should be loaded, design must be loaded. So, let us see whether this is okay or not. So, we had to load this same test bench only. So, we will load this, let us see what happens here. The error is caught here. So, what went unnoticed in during compilation, so got caught while loading the design. So, are you clear how deliberately you can create errors and then try to solve it, right? And you can just click on this, and sometimes it does not open the source code. So, because it is a load file, it does not open the source code. So, I will just read it out for you. Instantiation of sequential circuits failed because test bench makes it as sequential circuits with only one S, whereas within the design I deliberately changed it to 2S, right. So, naturally this being the test bench, because what we are loading is the test bench. So, here it is okay, but it is unable to find that particular design because we had deliberately changed. So, you can see that during compilation you will get errors also, even if it is free of errors, do not take it for granted, only at the time of loading the design you may find more. So, we will see one or two more before we wind up. So, this we can remove. So, we have removed the previous error too, and say for example, I said you should not use comma, and I have removed comma. That error was also there, but it went unreported. So, but you should be on the guard, probably some functionality got affected. You have to look into the schematic diagrams and find out whether all the functionality is okay. Otherwise, you have to take this .vm file once again generated and look into the simulator to make sure the functionality it is intact. So, I will leave this as an exercise to you. Just remove the comma for the normal functioning. So, if you inject a comma, then of course, okay. I have commented it out. That means to say I have removed the comma, it is equivalent to that. So, what I will do is I will put a comma, then we will see what it is. In fact, there are no errors here, right. So, let us see whether during load whether error is reported. Yeah. So, too few port connections it says, right. So, if you click on this, normally the source file must be opened if it is a relevant message, right. Too few port connections, you will have to find out why there are two port, right, because we have put a comma there, it was expecting more ports, to be listed. So that is why I think it is reporting too few port connections here, and port size does not match connection size in one more it says. So, but it does not open the 15th connection. Okay, 15th connection, let us see the source file. If you take this one, so if you just count 2, 4, 6, 8, 10, 11 here, 12, 13, 14, 15, no, it does not throw light. So, you will have to investigate separately, that would be a time consuming affair. So, you have to cautiously go, and the best way is remember to put comma for all the ports except for the last. And next one is, we will continue with the creation of errors and experimenting with the same in our next lecture. Thank you.